Hello there, and welcome back. What we're going to do in this video is solve this system, 2x minus 3y equals 3 and 5x plus 4y equals 65, using the addition method. So remember, one of the key concepts with the addition method is that we want to be able to add the two equations together and make one variable disappear. In other words, we want to make the coefficients of one of the variables opposites so that when we add them, the variable disappears. Notice that we can't just simply add them as they are, and it looks like it's going to be difficult to just multiply one equation by a number. But if I look at the y terms here, I notice that if I multiply the first equation by 4, I was going to use, even though I should be multiplying both sides by 4, I'll write it out, 4, and multiply the second equation, both sides of the second equation by 3, that's going to make a negative 12y in the first equation and a positive 12y in the second equation. So doing so, let's just rewrite that. So we have 8x minus 12y equals 12, and we have 15x plus 12y equals 195. And if we add those equations together, now notice the y terms do drop out. We have 23x equals 207. Great. Now we can easily solve for x, so we'll divide both sides by 23. And that gives us x equals 9. Now, great, so we have the value of x. Now to find y, we go back to one of the original equations, doesn't matter which one, because you remember the solution is the value of x and y that simultaneously make the equations work, or make the equation true. So I'll use the second equation just because it has pluses in it. 5x plus 4y equals 65. Substitute 9. And then simplify. So we have 45 plus 4y equals 65. Subtract 45 from both sides, and that means y equals 5. So it means our solution is, now remember, we can write this a couple different ways here. We could write x equals 9, y equals 5, or as an ordered pair, we have 9, 5. And that's our solution to the system by the addition method.